Welcome. We're going to solve inequalities, and specifically a system where we're going to have two of them. First, we're going to graph this line, and I'm going to graph it as if it was equal so we can figure out where the line is first before we do anything else. So that means I have a y-intercept of 1 and a slope of 2 over 1, which means going up 2 and over 1. Up 2 and over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. Or I can go the opposites, down 2 and over 1 the other direction. And it makes for a nice straight line. With inequalities, we also have to decide if the line is a solid line or a shaded line. And this little line underneath tells us it means it's equal to also, which means it's a solid line. The other one that does not have the equal sign underneath it there, that one we would be doing a dashed line. But we won't do that one yet. Okay, let's take the ruler and let's make a somewhat straight line here. Through the points. I can get them just right. A little off on that one. Okay. So this is one line. Having done that line, now we're going to test the area. We're going to test it to decide which side to shade. So I'm going to use the original equation, and I'm going to test it with a point. The easiest point to use, if it's possible to use, would be 0, 0, as long as it's clearly on one side of the line. If you're going through the line, through 0, 0 with the line, then you can't use it. You have to pick a different one. So in this case, I'm going to use 0, 0. And it means I could put a 0 in for the y. It's greater than or equal to 2 times 0 plus 1, or 0 greater than or equal to 1. Well, 0 is not greater than or equal to 1. It's false. And because it's false, it means we don't shade there. We shade the other side. I'm not going to do a whole lot of lines over here, just enough so that after I get the second line done, I can figure out which of the regions is the right one to shade completely. Now, let's take a look at this one. We're going to use the y-intercept, and then we're going to use a slope of -1, which is -1 over 1, or 1 over -1. So we would go down and then over, or we would go up and then over the other direction towards negatives. So first we have to go to where +1 is. Oh, I have the wrong one. I'm looking at +1. I'm thinking something's off. We're going to where +3 is. 2, 3. There. I'm going to do that one in blue so it matches the 3. And I'm going to start with -1 over 1 here. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, backward. And then I'll use this one, going up 1 and over 1 the other direction. And then I'll use the ruler. But before I draw it, I have to make certain that it's either a solid or a dashed line. And already we saw, first get this placed exactly right. Oh, I believe that's good. But this is a dashed line because the inequality sign here is not equal to underneath it. So some dashes to write. Okay, I'll finish these by hand. Oh. And now we have to shade for that one. Again, 0, 0 is best if it's on one side of the line, and it is. So I'm going to go back to using this original, y less than -x plus 3. I'm going to use 0, 0, so I put 0 is less than 0 plus 3, or 3. 0 is less than 3, that's correct, so that means it's this part that's shaded. But here there's not, and it has to be where both are shaded at the same time. And that looks like it's this area here. doesn't have to be perfectly shaded, but as you can tell, I'm making sure that it's very clear that it's this region. And every single point on that region would satisfy these two equations. It would either be make this one where the y is greater or this one where the y is less. Every single point there, we would plug in the x and y and it would be correct, going all the way out to infinity from that one. Now let's take a look at this next one. This one has a couple of things that are different from usual. First one is, on this first one, there is no y-intercept, which means it's 0. On the second one, it doesn't show the slope, which means it's 1, and the y-intercept is 0. And plus, this is 1 to recognize that if it was y equals x, that's a constant diagonal that goes like this. You can graph it with slope and y-intercept, or you can graph it with a table, but you're going to get this line automatically every time. And notice I remembered that it was dashed. The other one is a solid line. Okay. Because of that, it's a solid line. So since the y-intercept's 0, oh, wait a minute. First, let's come on back to this one. And let's check it. I can't be 0, 0. So instead, I can use some other number. Pick any one I want. I'll go way up here, and I'll use where the x is 0 and the y is 10. And so if I put 10 in for the y, and I'm going to use that greater than, 10 is greater than 0. That means this side, that is true, so this side would be shaded. Now let's do the second one. M equals negative 1/2. Y-intercept is 0. So I'm going to go to 0, and I'm going to go down 1 and over 2. Down 1 and over 2. Whoops, I went over 1. So let's now be more careful and go down 1 and over. Down, whoops, I still went through it. Down 1 and over 2. Looks more like about there. Down 1 and over 2. Down 1 and over 2. All right, now that makes sense. And I can do the other one where I go up 1 and over 2 the other direction. That's enough to draw the line and to recognize and notice that it's going to be a solid line because it has equal sign. Get this back there. Okay. Now again, that one can't be shaded as 0, 0. So I'm going to test it with 0, 10 like I did the other one. I put 10 in for the y is less than, well, negative 1/2 times 0 is 0 plus 0. So 10 less than or equal to 0. Well, 10 less than 0, then that is not true. That means we can't shade over here. We have to shade this way. And that shows that the part that's shaded together, where they overlap, is this one. And that would be the solution looked for here. So there are 3 things that someone looks for to see if these are correct. First, are the lines in the right places? Second, are they solid or dashed lines? And then third, where is it shaded? Where is the place it's shaded? So that's 3 things that you want to be certain that you know how to do to get these correct. Let's look at the one on the bottom now. Just another one for practice. We're going to use the y-intercept each time first to graph it. Okay, so we use those y-intercept plus 1 and at a negative 4. Now for the first one, the slope is negative 3 over 2. So that's negative 3 over 2 or 2 over negative 3. So I'm going to go, I'll start with this first one, which means I'll go down 3, but then over 2 towards the positives. Down 3 over 2, down 3 over 2. On this one here, I can do up 2 and over 3, up 2 and over 3, up 2 and over 3 that way. Okay, oh, I up 2 over 3. Oh, you know what? I made a difference. Hold on, let's fix something. I made a mistake. I accidentally used partially the reciprocal, which means I need to redo that. Good thing I noticed this doesn't quite make a straight line. So sometimes when an error like that happens, go back and fix it and think carefully about it. So what I did is I meant to make negative down here, but I have to keep the numbers in the same place. That means that 3 means we'll go up, and that negative 2 means we'll go that direction. So up 3 and over 2. Now it's correct. 2, 3, and over 2. This one is a solid line, if I can see from this. So let's make the line. Difficult to get it exactly right there. Now, I believe I got it right. So 0, 0 is very barely on that side, but it clearly is on that side. So I'll take advantage of that by putting 0 in for y greater than or equal to negative 3 over 2 times 0 plus 1. So that becomes 0. So 0 is greater than or equal to 1. That's false. Because that's false, that means we won't shade there. We'll shade like over here. Or we'll get ready to shade for part of that other side. Okay, now let's look at the second one. Start with the y-intercept and then a slope of 5 over 1, which means up 5, 3, 4, 5, and over 1, 3, 4, 5, and over 1. And this one is a dashed line. So let's do ruler and do it dashed. Dash. Oh, that moved along more than I wanted it to. Okay. Again, 0, 0 is on the outside, on one side of it clearly, so we can use that. 0 less than or equal to, first becomes 0. 0 less than negative 4, that's not true. So we don't shade there, instead we shade on the other side from where 0, 0 is not there. So this whole part is what's now shaded. So every point there will make both of those equations correct. Let's look now at some other examples. All of these were set up with y's. Here on these, we have to change. We can either change them through doing a table of values or through making an xy or making slope-intercept form. So I am going to change this one into slope-intercept form, which is y equals mx plus b. So that means moving the 2x over first. So I get negative y. And I'm going to temporarily do this as an equal sign. Minus 2x plus 3. This negative can't stay there, so we have to divide by negative 1. So we get y is equal to 2x minus 1, so it has to be a minus 2x minus 3. So the signs change on all of them. So we can graph that by going down to negative 3. And we have slope of 2 over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. Okay, because that means we'll be going up and then we'll be going over 1. Now, this one is a solid line. So let's go ahead and make a solid line there that goes through these points. And we can test 0, 0 here. So 2 times 0 minus 0 less than or equal to 3. That's 0 minus 0, which is 0 less than or equals 3. That checks, that's good. Therefore, that side here is where we would consider shading. Now let's do the second one. This one I'm going to do with an XY table. So I'm going to pick a couple points like negative 2, 0, and 2. So if I put negative 2 in for x plus y less than 2, add 2, y is less than 4. But it's y equals 4 that allows us, that gives us the a point on which to draw the border of it. Now, when I put 0 in for x, y is simply 2. And when I put in 2 in for x, 2 plus y less than 2, subtract 2, y is less than 0. Okay, so we'll put 0 here. So let's see if those give us a straight line. And according to this, it'll be a dashed line because there's no line underneath it. -2 and 4, 0 and 2, and oh no, those are points. Those points? Those are points. Oh, 0 and 2. I went down too far. 0 and 2, and 2 and 0. And then this is a dashed line. Well, again, nicely, 0, 0 is on the outside of it, does not touch the line. So let's check with 0, 0 here. If I put 0 in for the x and 0 in for the y, I get 0 less than 2. Okay, and 0 is less than 2, so I'll shape this side of it where the 0 is. And that means that this is the area where both are shaded at the same time, or where both of the solution, both of the equations or inequalities would be correct in this area, both at the same time. Okay, let's take a look at another example. And again, these can be changed doing y equals mx b or slope-intercept form or doing a table. So I am going to start with changing this one. Move the 2x over and divide by the -5. We get y equals 2 over 5x minus 4. And so I'm going to go to -4 and go up 2 and over 5. And I will put this line in place. And it is supposed to be a solid line. And then I'll check 0, 0. Going back to the original, becomes 0 minus 0, or 0 is less than 20. And that is true, therefore this area would be shaded. Now let's do the other one here. Okay, 6x plus 3y less than 12 becomes y equals -2x plus 4. All right, so I'm going to go to a +4 and use the slope of -2, which is down and over 1. Down 2 and over 1. Down 2 and over 1, down 2 and over 1, down 2 and over 1. And according to this, it's now a dashed line. Or this one is a dashed line. Now let's check it with 0, 0. Using the original, that's 0 plus 0 is 0, less than 12. That's a true statement. That means it would be this part that would be shaded, which specifically means it's this one where both are shaded at the same time. Okay, let's take a look now at this next one. Same exact idea. Let's change the forms, let's graph them. And so this first one becomes y equals 3 over 2 x minus 4. I'm going to go to 4, -4 rather. And go a slope of up 3 and over 2. Up 3 and over 2. That was not the spot, but this is. Up 3 and over 2, up 3 and over 2, Okay, and this one is a dashed line. Okay, come on. Sorry, this takes so long. Even the rulers don't cooperate with me perfectly. All right. And we have a dashed line here. I'm a little bit off, but that won't matter too much for checking 0, 0. 0 goes into here and here, and we end up with 0 less than 6, which is true. So that means somewhere over on this side would be the part that gets shaded, one part of that other side there. Now let's do this one. Figure out that for 3x plus 4y is less than negative 12. That gets worked out to move everything around, and it's y equals negative 3/4 x minus 12. Oh, wait a minute, I forgot. I did not divide by the 3. Because when I divide by 4 at some point early on, or here in it, that means I get a minus 3 there. Okay, that's better. Let's go to negative 3, 2, 3, and that's negative 3 over 4, which means down and over, or 3 over negative 4, which would be up, but then over that direction to the left. So it doesn't matter which one. Let's start off, I think, with going up 3 and over 4, up 3 and over 4. Now come back down here and go do this one, which is down 3 and over 4. Down 3 and over 4. And that's also a dashed line. Okay, sooner or later I'll get this in there. All right, there's the dashed line. And 0, 0 again is on the outside of it. So here I can put 0 into the 3x, 0 plus 0. So we get 0 less than negative 12. Okay, 0 is not less than negative 12, so it's not where 0, 0 is, but it's the other side that gets shaded. This next part, solved by graphing, has some what exceptions are. In a way, these are almost too easy. What you have to remember too is that y equals are going to be horizontal lines, and x equals are going to be vertical lines. So this one here is a horizontal line at 3. So I'm going to go to 3, and I'm going to do a solid line there. And these are y's that are greater than 3, so I don't even really have to check a point. I can just see, oh, they're greater. And y is less than 5. So 5, I'll use this one. Y is equal to 5 here. Oh, I'm supposed to be dashed. Okay. And it's all the numbers that are less than 5, so they come here. The overlap is this in between. So it appears that only one small patch, although it's a long patch, might continue going all the way around the world. But all the solutions come from inside there. Now, this could have been written differently if this was reversed, or if this was reversed, or both were reversed. Then the shaded areas would be different. The lines would stay in the same place, but the shaded areas would be different. Here's another solved by graphing problem. And we have a vertical line here and a horizontal line. Whoops, I said them wrong. Horizontal line for the y and vertical line for the x. So for y and negative 4, we go to where negative 4 is. and it's a nice solid line along there. You can do that one by hand, close enough. And then x equals 7 would be here, 5, 6, 7. And that one is a dashed line, so I'm going to do little dashes up and down. Okay. Now for both of those, let's check here. Well, actually, just y's that are less than 4 are going to be down here, and greater than 7 are going to be over here. So clearly this is the area. So we'll go back to red for that. This is the area that's the correct answer. And lots of numbers besides that, because they're all passwords you write down in class, but rather all of them out in every direction as long as it sticks to that quadrant. The next one has 2 x's. So let's see what happens here. I guess I'll do that one in blue. So that means they are both vertical lines. So we'll go with 2. And it's all the x's that are larger than 2, which means it's going to be 3, 4, 5, and all of those. The other one is x is less than 0. Okay. 0 is this line, x equals 0. And I'm going to use the words dashed here to make sure it's clear. And these are all the x's that are less than 0. Oh, so none of them actually intersect. When that happens, the correct answer is no solution. And that's the only thing to say in those cases, that there is no possible solution. There are no coordinate points where you can put, which will solve both of these at once. No coordinate point at all, or no x values, particular in this case. Okay, now the last page here are just simply more practice problems. So I'm going to graph them back to all 3 of these. If you were watching a video, you could stop the video, go and do these problems, and then come back and pick up the video for when I start talking about them in a moment. Go ahead and do that now. All right, let's now welcome you back and graph these. This first one I'm going to use +1, and then slope of -3 over 4, +4. So it's 2, 3, 1, 2, 3, 4. 2, 3, 1, 2, 3, 4. And then I could go the other direction, 3 and 4 here. As a solid line. And since 0, 0 is clearly on one side of it, I can check it by saying 0 and 0, so we get 0 greater than or equal to 1. 0 is not greater than 1, so we'll shade the other side from where 0, 0 was. All right. Now the next thing, and I'll do this one in blue, I'm going to change that one, and it becomes y equals, and I'll just do it with equals, -3 over 4 minus 2. So I'm going to go to the -2. Oh, that's -1. I'm going to go to -2. And then -3 over 4 is down 3 and over 4. Down 3 and over 4. Down 3 and over 4. And this one is a dashed line. Okay. And then this one is shaded, well, let's check 0, 0 for that. 0 and 0 makes it less than -8. No, that's false. Therefore, we don't shade with 0, 0s, we shade this way. And there are no places where there's an intermittent in where they connect, no connection. That means, once again, that the solution is no solution. That's what you save for the solution. Okay, let's do these last couple more. I'm going to change these so that this one is y equals x minus 4. And then the second one, y equals x minus 8. So first, this one, I'm going to do this one in black. We go to minus 4. And the slope is 1 over 1. So it's actually going to be something like that. And now I'll check 0, 0. So if I put 0 here and 0 here, I get 0 is less than or equal to 4. 0 less than or equal to 4 is actually true. So therefore, this one would be shaded this way. Okay, on the next one now, move the x over and divide by the negative, and you get y, or at least for the point, y is equal to x minus 8. So now I'm going to go up to, or down to negative 8. 2, 3, 4, negative 8. And the slope of 1 over 1 and 1 over 1 is going to be, oh, is this one solid or dashed? This one's solid. Okay, partway through it, so I should check. And now let's check 0, 0 for this one. And 0 and 0 is greater than or equal to 8. That one's a true statement, so we'll shade this side for it. And you can see now that the place where they connect together, oops, I think I went too far. Did I go which way here? 0 less than, oh, I made a mistake here. Hold on, let's come back and let's put these up. On the first one, 0 less than 4 is true, therefore I do shade here. On the second one, 0, 0, 0 is less than or equal to 8. 0 is not, or is greater than 0. This one's greater than 0 is not greater than 8. Have to think very carefully about these. So for this one, it shades this way. So I'm going to double check and think about it. Like the 0 and 0 there, less than 4 is true. So this side's good. Here, 0 is greater than 8 is not true. So this side is where we shade and the other side's not good. That means there's no intersection place, and that means this is no solution. Last one here gives a different type of thing. Go ahead and do this one and then come back and see it and see how it works out here. Go ahead. Okay, welcome back. And I'm going to show this one is y less than or equal to x minus 4. Oh, let's put that in there. And it's a solid line. This is just like in the last problem. It's actually the same numbers, but it's going to be a different result. It's the inequality signs are different. So if we put 0, 0 back into here, 0 and 0, we get 0 greater than or equal to 4. And now in this case, 0 is not greater than or equal to 4. So now I'm very carefully recognizing it goes on the other side. Let's use blue for this one. That one becomes y equals x minus 8. And so I will go to negative 8 right here. And then it's 1, 1, and it's a solid line, up 1 and over 1. That goes this way. And now let's check 0, 0 here. 0 minus 0 is 0 less than or equal to 8. That's actually true. 0 is less than 8. That means we're shading this way. So what we have here is where both areas are shaded at once. That means that any point in there will satisfy both of them at the same time. And that's how you show the answer like that. So for all of these, some of them are shaded and you show the area like it's shown in all these examples. And then you get some where there's no place, they're both overlapping, they're shading, so that means it's a no solution. And there were 3 no solution examples here for all these. Hopefully that helps to recognize what to do with these, and I hope this was helpful. Thank you for listening and watching.